Okay, we'll go ahead and get started with the Learning Target 2. We're going to multiply and divide radical expressions today, much like we did with the fractions in our past unit. So just like our previous unit, radical, we'll expand on this as we go, but basically, for now, you want to have only one square root or only one cube root in your answer. So one radical. No. Later on, we'll talk about what's possible. But right now, it's just if there's two square roots, try to make it one. If there's two cube roots, try to make it one, and so forth. All right, and then there's two rules. If the nth root of a and the nth root of b are real numbers, then the nth root of a times the nth root of ab. All right, now that's a bunch of math language, but what is it telling you you can do? You can multiply, combine them. Yeah, if they're both square roots, okay, so I'll make up an times the square root of. If they're both square roots, check, they are. Then this property, 2 and the 18. In other words, we can multiply the radicands. So it becomes the square root of 36 in this example, which is a nice number to have. Square root of 36 reduces to 6. But the property does say they have to both be square roots. Property, which is kind of the converse of the first statement, says if the nth root of ab is a real number, then you can take that, the nth root of ab, and break it apart into two nth roots. All right, that might be helpful, might not. We'll see. It's definitely helpful with the division one, and we'll see that on the second page. Again, example 1. Can you reduce, or can you simplify square root of 3 times the cube root of 2? No, why not? Exactly. No, different. No, different indices. Number 2, square root of 3 times square root of 12. Square root of 3 times 12, which is square root of 36. Nice number to have. Reduces to 6. And notice you said negative 6, right? So that's the whole principal root thing. Number 3, cube root of 2. Can you have the cube root of a negative number? Careful. You can't have the square root. All right, but can you have a negative under a cube root? Well, remember, are there negative? Move on. They're cube roots, so yes, you. And if you look at your reference sheet, you may not be as familiar. Is it on there? It is. Cube root of 8, negative 2. So this reduces to negative 2. Fourth root of 5 times the cube root of 3. Can you multiply those? No, and the explanation, because different indices. For a fourth root, index for a cube root is 3. All right, now these next two, 5 and 6, I want you to try them. They are Learning Target 1 problems. So I'd like you to try before we get into the of multiplying radicals. If you need a little help, I'll be working them up here, okay? But try them on your own if you can. The first thing I think about is the square root of 200 and list. Square root isn't on the list. The square root of x cubed, well, it does have a perfect square in it, but there's also a leftover x. So the two things that reduce are square root of 100 and square root of x squared. So we get 10x on the outside. But what's on the inside? Yeah. So 10x squared to 2x. Does your x in this absolute values? Now, at this time, I'll remind you of the shortcut that we came up with at the very end of the lesson. So if you can't remember anything else, at least this shortcut will help you. Is it an even index? There were three checklists. One, was it an even index? And an even index. Is x cubed, is that exponent also even? No, so it failed the second check. So then you don't. Number 6. Cube roots. 250, is it on the list? No. Is there a number on the list that might divide into 250? 125 might. Take your calculator and see. 250 divided by. You can make 1 out of it. 1a cubed with a squared left over. And b to the 8th, you can make 2b cubes out of that with 2b's left over. So there's a lot going on in this problem. So to keep it straight, if I'm going to reduce the square root or the cube root, and I like to circle anything that I'm not reducing, it just helps me kind of keep straight what's. All right, so one at a time. Cube root of 125. Root of b cubed and another cube root of b cubed. When that comes out, there's b times b, so it would be b squared. And what's left over is under a cube root. So cube root of 2a squared b squared. That's the test. If you felt good about those two, you're gonna feel fine about learning target 2. But if you still are struggling with those, you just need to work a little more with learning target 1, because 2 is basically 1 with an additional step. All right. Number through 12. Square root of 5 times the square root of 20. While you could reduce the square root of 20 because it's 4 times amendment, go ahead and make this into 1 square root and then reduce. So square root of 5 times square root of 20 is the square root of, oops, change back to blue, square root of 100. 5 times 20. That's what the property said, right? You multiply what's under the square roots. So square root of 100 is a nice number. We get 10. Number 8. I want you to pretend with me for a second. Let's pretend that that was 2a times 3a squared. What would you do if that were 3a squared? You do 2 times 3 and say 6. And you do a times a squared, which would be a cubed. So you kind of multiply the things out front, the coefficients in that example, and you multiply the a's, right? Same thing here. You multiply the 2 and the 3, get 6. And then you multiply the square roots. 5 times 10, which is 50, and x cubed times x, x to the 4th. And then we'll try to rewrite the square root with any perfect squares. So 25 times 2, x squared, x squared. And everything reduces except that 2. Exactly. Perfect. All right. When it comes out, if you'll remember, I'll scroll back up. 6 times the square root of 25. Actually, that's not in the definition there. This is 6 times a square root, so it becomes 6 times the square root of 25, so it becomes 6 times 5. So we get 30. And then we've got square root of x squared and square root of 2x is right, so x squared and square root of 2. Final answer. Do we need absolute values? Definitely not when it's an x squared answer, right? Number 9 through 12. We got to shift our mind, cube roots. So take that calculator, negative 16 times 12. Cube root of negative 192. A squared times A cubed. Now, we cross our fingers and we look on our reference sheet because we're not sure about our perfect cubes just yet. And is negative 192 on the list? Not. So that means we're going to look at numbers below or smaller than 192 and see if any of those will divide into 192. So calculator in hand, looking at the list. All right, the first one I tried is 64. Does it go in? Does 192 divided by 64? It does. Now, so do you use the 64 or the negative 64? Typically, we go ahead and use the negative 64 so that we can go ahead and reduce that. So negative 64 times what? Times 3 times a cubed. The 3. All right, running out of room, so I'll to the side. Final answer? Negative 4. Yep. And then an a, because the cube root of a cubed, yep. And then the 3 is still left under. Okay, you try 10, 11, 12, and you can. That should be 2 times 50, should be 100. Under there. You know, I think we can. All right, so you've had a chance to number 10. Any questions on number 10? All right, then your mind has thinking perfect squares anymore. You're thinking. So the 4th root of 4 times 8, 32. A cubed times a to the 5th, a to the 8th. Fingers crossed, we're looking at that 4th power. Mean thing going on. Yeah, there's a 16 in there. So we can use our 16 times 2, a to the 4th times a to the 4th. And everything reduces except that 2. And I've done this in the homework too. When you see the 4th root of 16, there's 4 because you're used to seeing a square root looking symbol and a 16, and you're just used to writing 4, right? Just be careful. So the 4th root of 16. Number 12 for multiplication. The 2 and the 5 on the outside should make a 10. 2 times 5, cube roots of negative 512. Fingers crossed, we're looking at our cube list. And it worked that time. Fingers crossed worked. So what is the cube root of? It is negative 8, which means your answer will be 10 times negative 8. Negative 8. bad, right? Especially if you feel like target 1. Division will go a lot faster. There's really 2 types of division, and we'll talk about the other division, target 4, when you have to rationalize a denominator. Look at the 2. If the nth root of A to B are numbers, and B is not 0, root of A divided by root of B equals the nth root of A to B. What's that telling you can do mathematically? It's telling you that if you have 2 different roots or 2 different cube roots, the second is telling you just the opposite. It's telling you if you have a fraction in the square root, number 13, simple is 1 fraction. Can we take the square root of 5 and say that 500 and that under the same square root, that fraction, would it reduce? Would the 500 divided by 5, and the property above tells us we can do that. The first property, which you can't see now, first property up there tells us you can do that. You can rewrite number 1 as number 13 as the square root of 500 over 5, which reduces to the square root of 100, which is 9. Of 100 reduces to answer. Number 14, we don't even need that property, although it would work. We recognize the square root of 64 to 16. Those are both perfect squares. So the square root of 64 is 8, and the square root of 16 is 4, yeah. So this reduces to 8 divided by 4, 2. Now, it would have worked if you'd taken the square root of 64 over 16, because you would have gotten the square root of 4, which you would have said is 2. So it would have worked either way. 15, you try it. Is it like number 13 or is it like number 14? It's like number 13, yeah. 3, you can't say that the square root of 3 is blank. So we want to try what we... Fingers crossed, when we make this fraction, the calculator will give us 3. You get what? You get 81, so square root of 81 equals 9. Perfect. Can you try 16, you think? Give it a try. It's not square roots. Cube roots. Can you reduce the cube root of 2? No, you can't because it's not on the list. It's way too small to be a perfect cube. So let's try the fraction thing. One cube root with a radicand that's a fraction. If that doesn't reduce, Paxton, give you... Cube root of 64 is on the list. Answer's 4. All right, last one. For this one radical with a fraction for the radicand reduces to, let's see, calculator says 500 divided by 4 is 125, which is a nice number. So final answer 5. In number 1819, we're going to use the formula backwards. If you have a fraction as a radicand, you can break it up into 2 different radicals. Let's see, so 18, does 25 divided by 4, in number 18, does 25 divided by 4 reduce for a fraction? No, it doesn't. But because 20, both perfect, you can rewrite this according to the property as the square root of 25 over the square root of 4. It's 2 different square roots, which do both reduce to 5 halves. 5 over 2. 2.5 or leave it as a fraction. With algebra 2, we like improper fractions. And algebra tend to use improper fractions more than decimals even. Fourth root of 625 at our reference sheet, and we see both numbers. So it would be yeah, that's right. So it would be helpful to write this as fourth root of 625 over the fourth root of 81, and that reduces to 5, and the 81 reduces to fourth root of 81 is 3. Number 20 with you, because now we have variables involved. But it's no different than when you reduce monomials in the last 2 units. Okay? The first step is just x cubed, and you wrote that as 1 square root, that the fraction would reduce. So do you see the 150 and the 3? You think, duh. I'll just put them both under the same square root and reduce them like we did in the last 2 units. We've had this target in the last 2 units. So how does that reduce? Does the x need an absolute value? Question, isn't it? Because you do see in this step right here, you see the x squared, right? But if we look all the way back here to the original 3 times x, if 3 is positive, x also has to be positive to make your radicand positive. So you don't need absolute values here. You look at the original problem, because as always, an original problem is giving you information. It's the given. So it's the square root of 3x is positive. So it's a given that 3 is positive, given that x. Question, Ian? All right, you try 21 through 23. And we'll pause the video while we try them.